Welcome to Prompt Engineering with the DeepSeek-R1 reasoning model. In this course, we'll explore how to effectively harness its advanced capabilities for real-world applications. We'll build from prompt engineering fundamentals through to sophisticated techniques that leverage DeepSeek-R1's systematic processing abilities. You'll learn to craft prompts that break down personal goals, manage multi-stakeholder communications, and translate business requirements into technical specifications. By the end of this course, you'll have practical strategies for using DeepSeek-R1's analytical capabilities across diverse scenarios. Let's begin by reviewing how prompt engineering techniques have evolved to leverage reasoning models like DeepSeek-R1. For users familiar with ChatGPT-style language models, DeepSeek-R1 represents an exciting advancement in accessible AI capabilities. It can methodically break down problems, consider multiple factors simultaneously, and develop sophisticated solutions with minimal guidance. As an open-weight model, it brings powerful reasoning capabilities to a broader audience. Today, we'll explore a new approach to prompting that takes full advantage of these capabilities. Before we dive into the advanced capabilities of the DeepSeek reasoning model, let's revisit some fundamental prompt engineering principles. Think of these as the building blocks that help us communicate effectively with all AI models. When working with any AI model, clarity is key. Rather than making vague requests, we want to be specific about what we need. For example, instead of simply asking for a business proposal, we might say, write a detailed proposal for implementing a new customer feedback system, including timeline and resource requirements. This immediately gives the model a clear direction and scope. The context we provide shapes how the model approaches our request. Just as you might brief a new team member differently for a corporate training project versus a customer-facing initiative, giving the model relevant background helps it align its response to your needs. This might include sharing who the audience is, what previous work has been done, or examples of what you're looking for. Of course, most projects come with boundaries, whether that's budget constraints, time limitations, or specific requirements. Being upfront about these parameters helps the model generate more practical and relevant responses. When it comes to output format, being specific helps you get exactly what you need. For instance, if you need a report, you might specify, structure the analysis with an executive summary first, followed by key findings and recommendations. This ensures you get a response that matches your desired format and can be used right away. Let's explore some powerful techniques that can enhance the quality of our prompts. These approaches help us get more precise, detailed responses that match our needs. Chain of thought prompting is like having a colleague walk you through their problem-solving process rather than just giving you their conclusion. If crafting a prompt that analyzes team productivity, we might ask the model to consider various factors like workload distribution, communication patterns, and resource availability before making recommendations. Breaking down complex problems helps generate comprehensive solutions. Instead of asking a broad question like, how do we optimize our operations? We might guide the model to analyze specific areas. Let's look at our workflow efficiency, resource allocation, and quality control separately, then see how they interconnect. Providing examples using few-shot prompting can clearly communicate our expectations. If we're asking for project status reports, we might share a couple of well-written examples first. This gives the model a clear picture of the style, depth, and format we're looking for. Modern reasoning models like DeepSeek-R1 fundamentally change how we approach prompting because they have built-in capabilities that previously required explicit instructions. These models naturally process information systematically before generating output. If you provide them with a complex prompt, they'll explicitly write out their analysis and problem-solving steps before providing their final answer. This built-in chain of thought processing means they show their work without being asked to do so. Their systematic problem decomposition is impressive. Give them a challenge like optimizing a company's meeting schedule, and they'll automatically break it down into manageable components and use a multi-step approach, analyzing current patterns, identifying conflicts, considering constraints, and proposing solutions, all without explicit prompting. What's particularly interesting is their self-validation tendency. You'll often notice them identifying logical inconsistencies in the output and correcting course. The output might include statements like, "Wait, I need to reconsider this because," or "Let me verify this calculation to ensure consistency." Perhaps most impressively, they excel at handling complex, interconnected constraints. If you give them a problem where multiple requirements affect each other, like balancing budget, timeline, and resource constraints in a project plan, they'll work through all the dependencies systematically, often identifying connections you hadn't even considered. Let's explore how to effectively prompt reasoning models by understanding 6 key principles. First, setting appropriate constraints is crucial. Rather than micromanaging the solution process, focus on defining clear boundaries and requirements. For example, instead of dictating specific steps, you might say, the solution must stay within our $50,000 budget and be implementable within Q3. Balancing structure and flexibility means providing enough direction to stay aligned with your goals while letting the model leverage its capabilities. Frame your prompts like a well-defined problem statement rather than a detailed instruction manual. With explicit versus implicit instructions, less is often more. These models have built-in reasoning capabilities, so simply present relevant factors and let the model determine the optimal approach. To encourage systematic thinking, focus on presenting the complete problem context rather than prescribing the analysis method. Instead of saying list pros and cons, you might ask, how should we evaluate this opportunity given our current market position, available resources, and competitive landscape? For complex problems, present the full scope and let the model handle the decomposition. The model will naturally identify components and relationships. When providing context, share information that directly impacts the problem space but avoid overwhelming the model with tangential details. Think of it as briefing a highly capable consultant. Remember, the goal is to harness these models' natural reasoning capabilities while ensuring they remain focused on your specific needs and constraints. For our first demonstration of DeepSeek-R1's capabilities, let's examine a simple but effective prompt that demonstrates the power of systematic problem analysis. Looking at this prompt, note its structure. The user presents 3 distinct goals: establishing an exercise routine, learning piano, and developing a writing habit. The key element that makes this prompt effective is the final line requesting analysis of interdependencies and conflicts before suggesting an approach. This open-ended request allows for comprehensive analysis. Before providing a structured response, the model creates a detailed reasoning section where it works through the problem systematically. This explicit reasoning process reveals how complex problems are broken down and analyzed before solutions are proposed. The systematic analysis begins with problem decomposition. Watch as each element is methodically evaluated. This exemplifies DeepSeek-R1's systematic approach to problem decomposition. The initial analysis identifies the common thread. All 3 goals require establishing daily habits, immediately surfacing time management as a core challenge. The analysis then uncovers potential conflicts in both time and energy allocation. Note the identification of specific risks, such as morning exercise potentially impacting energy for later activities. Particularly noteworthy is the discovery of positive interdependencies, how exercise could boost energy levels for other activities, revealing opportunities for synergistic scheduling. The analysis extends to practical considerations, equipment needs, space requirements, and time allocation. This demonstrates thorough consideration of implementation barriers. As the analysis progresses, it builds on previous insights to develop increasingly refined recommendations, considering factors like optimal time blocks, energy management, rest requirements, progress tracking. Now, let's see how this systematic analysis transforms into a structured response. Each element of the response directly connects to insights generated during the reasoning process. The response opens with key conflicts and synergies, directly drawing from the initial analysis of time, constraints, and energy levels. Notice how the early observation about exercise potentially boosting energy becomes a key consideration in the scheduling recommendations. The phased implementation plan reflects the reasoning section's emphasis on gradual habit formation. Phase 1 prioritizes exercise and writing, addressing the energy management concerns identified earlier. Phase 2 introduces piano practice once basic routines are established, following the analysis of resource allocation. Phase 3's optimization phase stems from the earlier consideration of long-term sustainability. The daily schedule template is a direct application of the energy management insights from the reasoning section. Watch how it places exercise in the morning based on the energy impact analysis. Piano practice as a post-work activity, addressing the cognitive load concerns. Writing in the evening, reflecting the earlier discussion about creative energy. Every component of this response, from the tools for tracking progress to the accountability measures, can be traced back to specific considerations in the reasoning process. This demonstrates how systematic analysis leads to comprehensive, well-reasoned solutions. DeepSeek-R1's thorough analysis ensures no critical interdependencies are overlooked. Now let's examine how DeepSeek-R1 handles evolving business requirements and complex stakeholder communications. The initial prompt presents a significant organizational change, transitioning from personal to company-issued devices within 45 days. Note the structured requirements and key considerations provided. The prompt specifies multiple deliverables: clear communication, impact analysis, security rationale, timeline, budget implications, and next steps. These requirements create a complex web of interdependencies. Equally important are the operational constraints: employee attachment to personal devices, department-specific workflows, limited IT resources, and business continuity requirements. Watch how the analysis breaks down these interconnected elements systematically. DeepSeek-R1's analytical capabilities shine in dissecting multi-stakeholder requirements. The reasoning begins with the email's entry point, crafting a subject line that communicates urgency without causing alarm. This demonstrates careful consideration of tone from the outset. Notice the methodical breakdown of department-specific challenges: sales teams' client relationship management, engineering teams' development environments, marketing teams' specialized software needs. The analysis transforms into a structured email that carefully balances authority with empathy. Each section directly addresses identified stakeholder needs while maintaining clear direction. Now watch how the model handles an additional layer of complexity with a second prompt introducing legal requirements for international employees. The second prompt introduces region-specific requirements: extended notice period, device monitoring options, device separation rights, translation requirements. The analysis immediately identifies the need to integrate these requirements without diluting the core message. Note how the reasoning systematically addresses each new requirement while maintaining the original communication objectives. The analysis outlines specific modifications needed: timeline adjustments for different regions, new sections for regional considerations, updated next steps reflecting varying deadlines, integration of compliance requirements. The revised email demonstrates how complex requirements can be structured clearly. Regional considerations are separated for clarity. Timelines are clearly differentiated. Compliance requirements are integrated naturally. Core message remains strong despite added complexity. This demonstration shows how reasoning models can adapt to evolving requirements while maintaining clear, structured communication. This demonstrates DeepSeek-R1's ability to adapt and refine complex communications while preserving clarity. In this demonstration, we'll see how DeepSeek-R1 approaches technical planning and architecture decisions. We'll examine how it handles complex technical requirements and business constraints in software development planning from an engineering manager's perspective. The prompt presents an engineering manager's request for a prototype customer sign-up flow with payment integration. Note how it combines specific technical requirements with business constraints and a tight timeline, creating a complex set of interdependent requirements that need careful analysis. The technical specifications span front-end development, payment processing, security, and user experience. The business constraints add another layer: billing options, data capture, compliance requirements, and a 2-week timeline. This creates an excellent opportunity to observe systematic constraint analysis in action. The analysis begins by decomposing the problem into manageable components while validating assumptions at each step. Watch how the reasoning process starts with fundamental architectural decisions. The analysis first considers the front-end framework choice, immediately connecting it to the constraint of rapid development. Notice the self-validation process as security requirements are analyzed. The reasoning initially suggests local storage, then immediately identifies potential issues. This demonstrates how the analysis process includes continuous validation and refinement of proposed solutions. The analysis systematically addresses each constraint while maintaining awareness of their interconnections. Here, DeepSeek-R1 demonstrates its ability to balance multiple technical and business requirements simultaneously. Watch how it balances the need for realistic payment processing with the prototype's constraints. Now let's examine how this systematic analysis transforms into a structured technical solution. The decisions section directly reflects the reasoning process, presenting clear choices with justifications. Each decision addresses multiple constraints simultaneously. React addresses both the timeline and maintainability requirements. Context API solution balances functionality with the prototype timeline. Payment abstraction strategy allows for future expansion while meeting immediate needs. The minimal viable architecture demonstrates how the analysis transformed complex requirements into a clear technical structure. Note how it accommodates both immediate prototype needs and future expansion possibilities. The code structure directly implements the architectural decisions. The payment interface component implements the abstraction strategy identified during analysis. The mock payment service provides realistic behavior for testing. The factory pattern allows for future payment provider integration. The identified risks and trade-offs demonstrate continued analytical validation. Each risk connects to specific technical decisions. Trade-offs are explicitly stated with their implications. Future scaling considerations are addressed. Finally, the success metrics provide concrete validation criteria derived from both technical and business requirements. Conversion rates address business needs. Performance metrics address technical quality. Mobile completion rates address user experience requirements. This demonstration shows how reasoning models can systematically analyze complex technical requirements, validate decisions throughout the process, and produce structured solutions that balance immediate needs with future considerations. The analysis particularly demonstrates how engineering managers can use these models to evaluate technical approaches before committing significant resources. DeepSeek-R1's systematic approach to technical analysis makes it an invaluable tool for engineering planning and decision-making. DeepSeek-R1 represents a significant advancement in prompt engineering approaches. Here are our key findings. First, DeepSeek-R1 systematically processes information before generating responses. This built-in analytical capability means you can focus on presenting problems clearly rather than prescribing solution steps. Second, define problems rather than processes. We've seen how DeepSeek-R1 excels when given well-defined problems with clear constraints, allowing its analytical capabilities to identify optimal approaches. Finally, use constraints as guidelines. Setting appropriate boundaries while allowing flexibility enables DeepSeek-R1 to leverage its full problem-solving potential. Let's examine how these principles translate to practice. In goal-setting scenarios, DeepSeek-R1 excels at identifying interconnected impacts and trade-offs. For complex communications, it effectively balances multiple stakeholder perspectives and requirements. In technical planning, it creates clear paths from business constraints to implementation decisions. These capabilities enable systematic analysis across personal, professional, and technical domains. By applying the prompting techniques covered here, you can now leverage these capabilities effectively in your own work.